Today we're going to talk about Ext JS in the embedded world. This means for most of us, the cars, fridges, but it could be actually anything, any electronic device. So it could be considered a very different area and very different to the mainstream web applications, but actually not at all. And even if you do not plan to develop a front end for an embedded device in the near future, there are many topics we'll talk about this morning you might be interested in. I especially think of modularity and data-driven. So what does user interfaces look like in the embedded world? This question worth to be asked because some might think they still look like this, some lights and buttons, but surprisingly not at all. And they actually look like something you know very well, something real-time, something interactive, data-driven. This is a concept we'll talk about later on again. Reliable and nice looking. But obviously that's not so simple, and we immediately think of hardware constraints. Because yes, we would have loved to, but we do not have that extensive, powerful clusters. You more have something like this little thing, and if you go into deeper details, you can see the difference. Most of the time, when you work on a web application, a standard web application, you have enterprise servers, which means dozens of gigabytes RAM, very powerful CPU, and to be reliable, you have redundant hard drives and a pretty good local storage. In an embedded equipment, of course, it's not all same thing. You have very little RAM. But that's not the main problem, actually. Currently, that's not the main problem in the embedded world. The problem is more about the CPU. And of course, you do not have any hard drive. So if you want something reliable, you need to have duplicate devices. And the local storage is very little as well. So if we have been in another world, just to summarize, you do not have this car, and you mostly have this little toy. So what are the consequences for developers? So you have to be really smart. That's, if we can say it in a few words, you have to be really smart because you cannot develop on your own computer, leaving the question of performances for later on. Patching an embedded system might be tricky. Sometimes you do not even have the network, so it's a different logistic. So actually, the application, the project we are going to talk about is a business case, and we really want to thank Hager for letting us talking about the project we have been working on for the last 2 years with them. You probably heard of Hager because they manufacture some pieces of equipment you find in electrical cabinets. But actually, that's if you do not know very well this company, it's a pretty huge company. They make more than 1.5 billion turnover, and so it's a German brand, and they are very well known for the quality of their products. And that's very important because when they decide to launch something, it should be perfect, okay? You probably heard about what happened with Samsung. You can imagine how just a product the impact a product can have on the image of a brand. So what are we talking about? Where's it?
You probably have seen it in our booth yesterday, 2 days ago.
We don't have it. Do not have it. Oops, left it. So actually, it's a little piece of equipment. You can have an image here. What is it? It's a kind of smart box for an electrical cabinet, and this smart box is actually in charge of monitoring and helping operators to enhance the energy consumption, to save actually money, of course, and also the environment. So this piece of equipment is supposed to equip large facilities or buildings. So the project, can go back a little. This box is called a Gordius system, and it's as I said, it's supposed to help operators to optimize the building's energy consumption. So if you are used to that kind of domain, you probably know that there are other companies that supply with that kind of tools, that kind of products. But Hager really want to put forward the idea of having that kind of product and a very simple installation of and configuration, and that was one of our requirements. So, Leo?
Yeah.
Can you show us a bit of what the operator is supposed to have in his hands?
Of course. So basically, the Hager application is split into 3 main parts: the visualization part, the configuration part, and the preferences. In the visualization part, you will see lots of charts, D3 charts actually. Lots of grids to display the data, the information that is important. In the configuration part, you will have everything to configure the products that are plugged to the box. And that UI shows the configuration screen, the main configuration screen for the product that are plugged to the box. In the configuration part, you will be able to create alarms as well. So this product is meant to evaluate the power consumption and the power production, and the operators can create alarms if, for instance, one or another product will consume too much energy. So in the configuration part, you can create alarms as well, and many other features, but we won't see them in details. That UI is part of the visualization part, so it has a little dashboard in it, which shows the energy consumption. On the left side of the screen, you will see pie charts that represent split energy, the energy that is consumed by usage, for example, by lighting, by the heating, by the ventilation, energy distribution per zone as well, like floor by floor inside the building. And on the right side, you will see bar charts. All those charts are D3 charts. They look like standard Ext JS chart, but we'll talk about it later. And on the right side, you will see trending of the energy consumption. It's just a comparison with last month consumption. So that's it for that UI. The last piece of UI we wanted to show you is another part of the visualization screen. And it shows the power quality of the entire building. And and it's based on bar charts, grouped bar charts actually, and a little grid. Everything is bound to the same store. So that's the magic with Ext JS. So, target architecture.
Yeah, let's talk a little about the software now. So the application is composed of, we have the box now. So in this piece of equipment, you have a little web server, a Tornado web server based on Python. Little lightweight databases like MongoDB or SQLite. And this web server also generates Wi-Fi network around the box. This web server is supposed to provide with the Ext JS application itself to the operator, and also, of course, many web services and also WebSockets. So actually, when the operator arrives in the area of the Wi-Fi network, he's supposed to have a little pop-up screen saying that, oops, you are in a new network, would you like to open this URL? And of course, this URL points on the Ext JS application. So the tablet or the laptop can be brand new. You just bring your own device. Tablet, nothing is installed basically on it. So what about the modularity? That's the important key point. Actually, this box just provides with the core services, just provide with everything that help the operator to monitor the energy consumption. But you have to know that actually this is not the full product. This thing can be, you can have plugins added to this box, and each plugin is supposed to bring new features. Could bring, for example, the features that help the operator to monitor the temperature. Another plugin can bring something to monitor the CO2, etc. And the target is to bring with this new module a new piece of server. I just put a red square on it. This is a piece of server, and also a new piece of client. And this has to run without any starting up, and just plug and play. So what does it mean in Ext JS? First thing, it seems to be obvious, but you definitely need censure command. Because if you do not use it, of course, you will have to download many big JavaScript, and of course, it's better to have one single minified JavaScript. And it's not because, again, it's not because of the RAM of the system, because in it's basically a very big embedded device. In it, you have dozens of gigabytes. It's more because of the CPU, because you have to provide those files, and you have to download these files, and it harms the CPU. So it seems to be obvious for most of you using censure command today, because you cannot even imagine don't using it in Ext JS 5 or 6. But believe me or not, we have many customers who are still using Ext JS 4. And as you may know, in Ext JS 4, if you don't want to use the censure command, it's up to you. So second topic, dynamic loading. This is the tricky part. So Leo, can you explain how it works?
Yes. So Jean-Philippe talked about it previously. So when you've got this box, which is plugged basically in your electrical cabinet, you will be able to plug other products. Natively, you will have a lot of features in it, but there are just native features. And you can plug other products. You can upload configuration files that correspond to that new products that you just plugged on the fly without any reboots, as he said. And transparently with those configuration files that are built by our customer, Hager, there will be pieces of UI that will be uploaded as well on the server. And then the backend in Python, which is in it, will be in charge to place those JS files at the good place to let the operator see the new pieces of UI in his UI. So the magic in it is that everything is loaded dynamically, like sort of plugin. The Ext JS app cannot be deployed as a single JS, so of course you'll still have your app JS files after the build. But what's important in that is that the physical modules that are linked to this, are plugged to this product, come with an Ext JS package. An Ext JS package that is built apart from the application. So you will have a build for the application, and you will have a build for each plugin, each module that you can bring after that and plug to this box. And that's the big part of the modularity. Because, for instance, if Hager says, OK, for us, we won't aim the management of temperature sensor natively. We won't have it on our application, but we will want to develop some packages that will come with the temperature sensor. And if one of our customers will plug this temperature sensor, he must be able to have, for instance, a new tab in a tab panel which contains new features about that temperature sensor. And that's the main goal of that modularity. So the other part is data-driven dynamic charts. As I said previously, we used D3.js for that. At first, we started with Ext JS standard, but Hager wanted some tailor-made charts. They wanted some low-level SVG customization, and so we chose D3.js. So it was the best pick. Actually, we had to build our own mapper to D3.js because it was before Sencha's announcement of support of D3.js. But making it on our own provides us with some issues with the support of different browser behaviors with SVG manipulation, of course. And so the long-term approach will be to switch to Sencha's official implementation to let Sencha spare us the job of browser compatibility, as I know. So what does it look like? In the previous slides, I showed you some pieces of UI that showed some charts. Here's a new one. It's a multiple line chart based on D3.js as well. So basically, what we've done is that we created a based D3.js chart class in Ext JS. As you can see right here, Ext define common d3.chart. It has several configs, and what we wanted to show you in that slide is that it's the data-driven part of it. In fact, we will take an Ext JS standard store, and we will map its data into a flat array, and we will map the fields of our store to match what is expected by the D3 chart. So the main goal is that you go on d3js.org, you go check for an example of a D3 chart, you take the code, you adapt it a little bit, of course, but you will look what kind of data, what kind of structure of data the D3 chart will expect, and you will be able to easily map what you've got as a structure in your store with what the D3JS chart expects. For instance, let's say you have an Ext JS store with the data that look like this. So these are some records inside the store. You see you've got in the structure of a record, you've got the value, the label, sorry. And you know that your D3 chart will want something more like value and label, not the value, not the label. So you just have to upload some field mappings to set field mappings in your chart config that says, okay, the value will turn into value and the label will turn into label. And the magic will be done, and our method that we built will return you a flat array. So it's not Ext JS data models in it, it's just a JavaScript array with the right structure. So that's the data-driven part.
Thanks, Leo. So the other interesting part in this dynamic plugins is actually Hagar wants to deploy this product everywhere around the world, of course, and they for the moment cannot expect what would be the country where this product will be deployed. So for example, basically on this thing there is no Chinese by default, but the idea is to put a plugin like adding a new feature, and in this plugin you have a new language. But you probably know that to do that currently you have to fill in a file where you put all your translation. You have to package with centric command a new app, and you have of course to redeploy it. So each time you need a new language, each time you need a new translation, it's a new centric command operation. And you have to reboot your system. So what we have done, and we largely advertise on it because it's a package you can find on the Sencha marketplace. You just have to download it for free if you want it for your own projects. The idea is just to have remote internationalization. The idea is to have all the translation in a database and having a REST API to collect the appropriate translation on the fly when required. Yep. So, Leo, can you explain us
how does it work?
How it works?
So, on the left is the Sencha guideline. So, one app, one folder containing the sources. In that folder, you will have the English localization, you will have the French localization, for instance, and when you build with a little config in the app.json, you will have one build in English, one build in French. So that's a great solution, but in our case, where we needed a lot of modularity, as Jean-Philippe said, we wanted to get further in that modularity. So our implementation is as simple as that. You've got your application, which is in English by default. It's in English. And then your application server will be able to give you back the French translations or the German translations when it's asked by an AJAX call, basically. So what it looks like is that you define a singleton. Let's say Jnesis labels. It's a singleton, Ext JS singleton, with all your translation, all your translated strings in it. So basically, by default, it's in English. And then in your application.js, in the launch method, you will load the necessary files. The necessary files may be based on a query parameters in the URL, or based on the local language of the browser of the operator, etc. So you get the new translated strings and the new language as a JSON file, for instance. And when you get it, you just override. I will show you. It's here. You override Jnesis.labels with the data. So the data, the JSON data that you will get, will have the same structure as that, and you just have to override your singleton. So every strings in that singleton will be replaced by the string translated in the good language. Everybody understand so far? Okay, thanks. And then after you've loaded the data and the translations, you will be able to create your first view. But that's not all. You will have also to override Ext component. It's really simple. You override Ext component, and you add it a localized property. If you see the bit of code over here, actually we are looping inside a localized property, and we'll get the proper string. For instance, if we take this string, localized title, which is jnesis.labels.title, if we make an eval on it, you will get what's in the singleton as a title. Okay, I can show you back here, jnesis.labels.title. So that's kind of what you will do in a binding way. You know, when you're binding a title, for instance, instead of localized, you will have bind, title, and then with the curly brackets, but without it, here, we just make an eval of that.
Thanks. Just to summarize a bit, maybe you understood that in the end, modularity and data-driven are two close concepts. Basically, if you really want to have a data-driven software, you definitely need modularity. A few other topics. We can talk about many things we have done in this project that helps to have a modular software, but actually there are just 3 or 4 additional topics we would like to talk about very quickly. First, of course, if you want to run your web app with that, you have to be very, you have to take care of the REST calls, because each time you call the API, each time the CPU has to respond to your query. And actually, what you just have to think about is if data is duplicate, so you do not need to download it again. So you have to really think about what can be stored locally on your Ext JS app and for how long. Of course, if you are using WebSockets like we use in this project, or server sent event, that's even more important. And of course, don't forget to request for compression on the backend, because all the modern browsers can now support compression. And the last but not least, if something can be done on your client, on the Ext JS, on the web part, on the front end, do that on the front end and not on the back end. So, for example, if you have to export files or proceed with the data sorting, do that with the Ext JS. So, as a conclusion, easy Ext JS, fit for embedded. Of course, yes. But developers must understand what's happening behind the scene. Although, yeah, Sencha did a really good job sparing this to developers in most other cases. But in this situation, because you have to optimize everything, you really have to understand what's happening behind the scene. And to summarize, again, keep in mind that the resources are very limited. Be smart, not just comprehensive, so that means design modular if you can. Of course, we cannot bring every features, all the possible features on it. So some customers will have 2 features, some other customers 2 others. And test, retest, and test again before releasing, because again, it might be tricky to patch this kind of things, even though today you probably know that most of those pieces of equipment are connected. So, making Ext JS work with things with big quotes. We're not talking about IoT, but it's nothing much than legitimate expectation for Ext JS is probably fitting with this world. And Jnesis is always looking for a solution to use Ext JS wherever it can be in a beneficial way for its client. And check us out at the sponsor zone. It's over now, but I invite you to come on our website, of course, to see what we've done. Thank you. We have probably 10 more minutes to, if you have any questions. Yeah.
With the modularity, is software versioning a problem? I mean, it seems like on that unit, you'd have one set of software.
Yeah.
And then on your modules, you can have different version of that particular module software.
Yeah.
And that unit was made yesterday. The other unit that someone buys was made last year.
Yeah.
The public module.
Yeah.
Is there an issue with software version match?
There may be some issues, but Hager will handle the process of what we hadn't said is that we didn't make the hardware part at all. That's our customer that handled it, and they have a plan to counter those kind of issues and to version as well as the software part. They will version the hardware part to clear the compatibility problems. And but yes, that's a.
Yeah, but across modules, the question is more across modules. You mean is the module A compliant with the core of the system?
Right.
Yeah. Okay. So I don't think I can have a definite answer because the project is not completely out, but completely released. But actually, thanks to this modular system, if you really want to change the configuration and and what's in a module, of course you can. It's not just something fixed and final. Yeah. So of course you know that in software development, if you want to develop something compliant with the rest of your code, yeah, it's up to you. So if we bring a new module and we update the version of this new module, it has to be compliant with the rest, of course. Yeah. Yeah. I don't know if you answer your question. I answered your question, but yeah.
Yeah.
To go to what you said, like the part that got built maybe 1 month ago, right? You shipped your application on it, right?
Yeah.
Yep.
Okay. Maybe you made some change, right? And maybe hardware made some change also.
Yeah.
And this month they will release some new parts, right?
Yep.
These new parts will have the new hardware, software, and maybe your new application.
Yeah.
Okay, that means the old will still continue to run with the old version, old application, or will you do some updates?
What we maybe didn't say is that when you plug a product to that box, you're talking about a compatibility with product and that box are different kind of versions. When you plug a product to that box, you will upload configuration files that Hager will provide to its customers. So Hager will provide configuration files that match the version of the main box with the products that will be plugged to that box, if you know what I mean.
Okay. See.
So if the box is in version 1.8 and they will plug a temperature sensor with a new part of the HMI, of the UI, they will upload a configuration file which is compatible with the version 1.8 as well. Any other questions? I think that's all for us. Thank
Thanks.
you.